I'm going to talk about the product rule for square roots today, and specifically how we use it to simplify square roots. And when we talk about this, a square root is simplified when a radicand contains no perfect square factors other than 1. So if we said that, then the square root, let's try this again. The square root of 20, if we had the square root of 20, that isn't simplified. We don't have this broken down. Because we could say, 20 is equal to the square root 4 times 5. Well, in this case, 4 is a perfect square. So when we simplify square roots, really what we're doing here is we're going to be factoring them to a point where we hopefully have perfect squares somewhere. So if we looked at this, if we said, okay, what if we had the square root of 9 times 16? Now, if we multiply 9 times 16, we get 144. We know the square root of that is 12. But let's look at this a little bit differently. And the square root of 9 times the square root of 16. Well, when we think about this, we're getting right into what the product rule for square roots states. And that's basically, if we have a situation where we have the square root of 9 times 16, we can break this down. This is the square root of, same as the square root of 9 times the square root of 16. Which, again, if we look at these, the square root of 9 is 3, the square root of 16 is 4, 3 times 4 is 12. Well, we match here. So when we're looking at this is what the product rule for square root states. Basically it states if, let me change this. Okay, so the product rule states if square root of A and square root of B, okay, so square root of A and square root of B are real numbers, then at that point, if we know the real numbers, then the square root of A times B is the same as the square root of A times the square root of B. Now, how does this help us? Well, this does help us when we get into factoring, really. So, the square root of product, when we look at it, is equal to the product of the square roots. So, if we looked at this, and we say, okay, we've taken these numbers here. Let's look at the square root of 45. If we break that down, we're saying that's the square root of 9 multiplied by the square root of 5. So if we want to simplify this a little bit more, the square root of 9 we know is 3. So we're looking at 3 times the square root of 5 is a simplification for the square root of 45. So, this is simplified as far as we can go because 5 is a prime number, has no other factors other than 1 and itself. So let's look at a couple other instances here and work through a few problems. Let's look at something like the square root of 60. Okay. We could rewrite this and we could say this is the same as the square root of, let's just put factors here. Let's say we can have 2 times 30. Okay. And we'll down. We can take this, so we have 2 times 30, now we can break 30 down to 2 times 15, and then we can break 15 down as well, so we have 2 times 2 times 15, 15 can be broken down into 3 times 5. So really we're looking at the square root of 2 times the square root of 2 times the square root of 3 times the square root of 5. So when we think about this, well, if we look at these through, 2 times 2 is 4. We can say we have the square root of 4 times the square root of 3 times the square root of 5. Well, we know 4, the square root of 4 is 2. So now we're saying, now we have 2 times the square root of 3 times the square root of 5. Well, 3 and 5 are both prime. We can't factor these down. We don't have anywhere to go with these. So we look at the square root of 3 times the square root of 5 is equal to the square root of 15. So our answer would be simplified as far as we can. 2 times the square root of 15 is how we bring down the square root of 60. We're really just factoring these numbers. We're we're factoring the prime factorization, but we want to also have perfect squares in that case. So let's look at another one. Let's look at the square root of 200. Okay. So we know we can break this down to the square root of 100 times the square root of 2. Well, the square root of 100, we know that's 10, so we're looking at 10 times the square root of 2. Another one we can look at real quick, and then we'll move on a little bit, and maybe we'll do a couple more here. Let's look at a number where we have, let's say we have 2 times the square root of 8. Well, for now, we're not going to worry about our number outside of our radical. For now, we're just going to look at the square root of 8, and we know that's equal to the square root of 2 times 2 times 2. Well, we can say the square root of 4 times 2, the square root of 4 times the square root of 2 would be a similar thing. So the square root of 4 is 2, so we're looking at 2 times the square root of 2 is 8. Okay? But the thing is, we have a 2 times this. We have this. So 2 times 2 is 4, so we're really looking at 4 times the square root of 2. Because once we factor the 4 out of here, the square root of 4 is 2, we have to multiply it by this number. To give one more example on this, let's look at a situation where we may have something like 5 times the square root of... we don't want anything too easy here. Let's say 80. Okay. 5 times the square root of 80. Well, the square root of 80 can be broken down into the square root of 4 times the square root of 4 is 4 times the square root of 5. 4 times 4 is 16 times 5 is 80. So the square root of 4 is 2, so we have 2 times the square root of 4 times the square root of 5. And remember, this is all times 5. There's a 5 here. So the square root of 4 is 2, so we're now looking at 5 times 2 times 2 times the square root of 5. So we get 5 times 4 times the square root of 5. Which means we have 20 times the square root of 5. So, sounds weird, but I find these problems kind of fun because we're really just doing a lot of factoring here. So hopefully this helps with the product rule for square roots. Next one I'll come in back with the quotient rule for square roots. Have a good one. Bye.